Um, Welcome everybody that is joining us. This is part of our Artemis Roach Challenge. I just closed the registration today. So if you're joining us today as a mission advisor, you're one of our selected chosen teams, and we're really excited to have you. And we want to support you as much as possible through the challenge. So this is one of our sessions that we're going to offer, 3 of these actually, where we're going to help you guys get through the different mission objectives, understand what they involve, but also just give you an opportunity to get together and ask questions of us. So that's what the point of this session is. We're going to try to keep it fairly interactive as we go. My goal for this particular session is just to kind of help you guys get set up on the challenge in general, like understanding what's involved in terms of like team submissions. And then because we have 3 of these, I'm actually just going to focus in on the first 4 mission objectives. We're certainly open to taking questions at the end on the other one, but we'll have other mission support sessions where we can focus in on some of the later mission objectives. It's just not enough time to think about all of them. Okay, so I already started talking, but I will go to the next slide and actually introduce myself. So my name is Dr. Darcy Snowden. I am the director of NSBE. I'm based at Central Washington University in Ellensburg, Washington, where I'm a physics professor. I'm also a little bit sick, so I apologize if I sound a little stuffy or if I hope I don't start coughing in the middle of this presentation. But yeah, I'm really excited to have you guys here. I am joined by Kim Weaver. Kim, I'll let you introduce yourself.
Hello, friends. My name is Kim, and I'm the STEM and EdTech coordinator at OESD in Bremerton, which is an educational area of Washington State. And my main role on this project is as the developer of the companion course along with the rest of the team. And so if you have any questions about standards or the lesson plans or the companion courses, you can direct them to me.
And then we're also joined by Deanna Marshall, who's my partner here at Central. Do you want to go ahead and introduce yourself, Deanna?
Hi, I'm Deanna. I'm the one that's probably been emailing you about what your equipment needs are. So that's me. I'm here in the office with our student assistants, and we are so excited and so can't wait to help you guys and see what your teams are doing.
Yeah, Deanna is bold enough that she might even call you on the telephone. So don't be afraid. She's very friendly. I'm of a young enough generation that sounds kind of terrifying to me, but she will do it. Okay, so I'm going to start off. This is our little outline here. I'm hoping, again, just kind of fire through some of this early stuff quickly, but I do want to give you guys some context for what you're gotten yourself involved in. The Artemis Roach Challenge is one of the many things that's done by the Northwest Earth and Space Science Pathways, which we always just abbreviate as NSBE for short. Notice our acronym is NESSP. Like a lot of scientific things, we developed the acronym before we fully understood what website domains were available. So it's different from our website domain, but that's because that one was already taken. But NSBE is basically, we like to say it's NASA's presence in the Northwest. So we are based in the Northwest, and a lot of our activities are based in the Northwest, but this particular one is nationwide. So this one's a little bit unique. But our main goal is to provide hands-on activities that are based on NASA missions and science. So we're really trying to get what NASA does out to the people, and the people in this case is K through 12 students and educators. And our focus in particular is on underserved and underrepresented communities. So for NSBE, of course, that means underrepresented groups, but it also means underserved communities can mean rural communities that are far from college campuses or other museums or NASA centers where you can get an authentic STEM experience. So that's why we are really serious about providing a lot of support and supplies to our teams, because we know that a lot of our teams are in places where it can be hard to find those things. So I just want to make it clear, there's only 3 of us here, but NSBE is a big consortium of partners. Here you can see the list of people that are, or groups, organizations that are part of NSBE. And of course, under each of these organizations, there are people that are part of NSBE. And so if you, for example, sign up for our newsletter, you will hear about programs that are being put on by some of these other organizations throughout the year. So as far as we're concerned, you're now part of our NSBE family, and we're hoping that you have a good time with Artemis Road and you're interested in doing some of these other activities that are offered by our NSBE partners as well. NSBE is part of NASA's Science Activation Program, which is what makes NSBE so cool. So we are funded directly by NASA. And in fact, NASA's Science Activation Program is really important to NASA. It is the part of NASA that is all about reaching the community with its science and missions. And that's really important to NASA because, of course, the community funds NASA to do its science. So actually, we own the science that NASA does. We paid for it, so we deserve to learn about it. And that's one of the things that NSBE does. NSBE is part of one of 54 teams that are part of science activation. A very common one that people have heard of. Another one is Astronomy Picture of the Day. And altogether, these 54 teams actually reach 20 million lunars across the US. So you guys are now, again, part of this science activation family as well. All right, so that's a little bit about NSBE. Since we only have a little bit of time and we've got a few people in person here, I want to learn about you guys. So Kim already asked you guys where you're from. Please go ahead and put in the chat where you're located so we kind of know where everybody's coming from. Looks like I see some already there. We got Idaho, California, Texas, Washington, California. Go ahead and add to the chat where you are from. If you can't find the chat, it's in the lower right-hand side. Looks like a little speak bubble. Okay. And you can also, if you want, you can unmute yourself. All right, we'll go on to the next one. Again, just to get a little context of who's here, let us know in the chat, or if you want to unmute yourself, if you've participated in Rhodes before, if you're new to Rhodes, or you've already participated. Okay, yeah, hi, Brandy. New to Rhodes, all right.
I'm going to add in, if you know your team number, drop that in also.
Oh, great. All right, I'm just going to go ahead and fire down this list. Just because, again, we're trying to see where people are at before we go down and help you understand some of the MOs. I'm curious about which MOs maybe your team has already completed, or if you know which ones you plan to do. Maybe you plan to do all of them. Maybe you just plan to do some. And then if you have particular MOs, if you're here with particular ones that you anticipate needing help with. So yeah, MO, sorry, mission objective. I'm using my jargon. Okay, thanks, Jesse.
We started in December, really, with an essay. We had 12 students write essays about the moon or the Artemis project or whatever. There were 3 different essay topics, and just trying to get people warmed up and excited about it, and they all read their essays at our last meeting, and we just got started with mission. We introduced mission objective 8 on Monday, and then we're going to start working on 1 tonight, actually.
Oh, great! All right, plenty of time. Cool. All right, great. So jumping around a bit. And that's totally fine, Stephanie. Start on 2, start on 4. Yeah. Okay, so like I said, we are going to focus on the first 4 today, but it looks like a lot of you guys have gotten started on some of them. At least all of you guys have maybe gotten started on the mission development log, the MDL. Okay, but that's useful to know. We're going to probably go through all of them anyways, because some people will watch this as a recording. So I want to make sure that kind of the initial content is there. I do want to say, as before we get started, we really appreciate you guys, your mission advisors, participating in the Rhodes Challenge. Really what we do, we're trying to reach all of these learners across the country. We can develop the material, but we really can't reach the students without you guys. So we really appreciate the fact that you take the time to do this with your students. I know for a lot of you guys, this is extra out of school time. So I just wanted to right off the bat, thank you guys for your participation. We really do appreciate what you do, and you do make an impact in the students' lives that you spend time with. Okay, so just quickly, what is Rhodes? You guys should all hopefully have some idea what you signed up for, but Rhodes is a program that NSBE has done annually for the past, I think, 4 or 5 years. And it stands for Rover Observation and Drone Survey. So Rhodes is an acronym. And really what we have is teams in grades 3 through 12. They're modeling their own NASA mission. So they're taking aspects that are kind of common to a lot of the missions, and they're modeling it, which means they're recreating a version of it for themselves in order to have a hands-on learning experience. We do take inspiration from real NASA missions. That allows us to actually infuse a little bit of what NASA is doing into their brains, which hopefully is exciting for them. And then they document their mission and submit their materials back to us for the chance to win prizes. So that's also a nice part of the challenge. We're focusing this one obviously on NASA's Artemis mission. I'm not going to spend a lot of time on Artemis. Hopefully you guys did the reading that's in the manual. And of course, Artemis 1, which is the first part of NASA's Artemis mission, which is quite like Apollo. It's going to be a years-long thing with a lot of launches and a lot of different types of flights. But Artemis 1, the non-crewed flight of Orion, which is the capsule that will eventually take humans to the moon, already happened. And hopefully you guys watched that launch and kept up with the mission, and maybe even watched Orion land safely in the Pacific Ocean. But there's more Artemis to come. Artemis 2 will be a crewed flight to the moon. They won't land on the moon, but they will orbit the moon. And then Artemis 3 is our big exciting thing. That's going to be the first woman and person of color to land on the moon. Okay, and that will be the first people to land on the moon since the 1970s. So it's been a really long time. So that'll be really exciting. Okay, so what do we do with that? So Artemis mission, very exciting. I'm excited about it. Hopefully you guys are excited about it. We take literally the people that are here and more people in NSBE. We put our minds together. We pulled out what we thought were some of the coolest parts that go into the Artemis mission, some cool aspects, and we diffuse those into the Artemis Rhodes Challenge. So we take these and we use these inspirations to make mission objectives, and that's how we build our challenge. Your guys' guide for the challenge is the Artemis Rhodes Manual, which Deanna just printed off a bunch of copies. You guys can print it off too, but of course it's also available online. And Deanna's putting the link to that in the chat if you guys haven't found it already. But the Artemis Rhodes Manual has a lot of information in the front, like information on the companion course and how to submit your results, some summaries of the challenge objectives. It has a reading about the NASA's Artemis mission in there. But then most importantly, it has the description of each challenge mission objective and specifically what to put in the team's mission development log, which we're going to talk about in a second. So that's your main guide for the challenge. If you just had that, you actually probably could get through the challenge. But we also have a lot more additional resources on the website. So I just like to remind people to visit the website and see what's available there. So if you go to, I should have made that URL a little bit more specific on top, but if you go to our website and then you click on one of the links that takes you to the Artemis Rhodes page, you'll see this little bit in the middle of the page, and each of those little icons like represent different parts of what's available in the page. The registration bit is closed now, but the challenge manual is linked on that page. The resources, that's on the bottom left there. If you click on that, you can find information about the supplies that we sent your team. So if you want to buy another LED light, or if you want to watch a video about how to build your fold scope, you can find that under the resource tab. All of the links that are in the manual, if you printed off the manual and you're looking at the links at the bottom of this printed off page, if you go to the resource tabs, all the links for all the mission objectives are also linked under that tab. And then there's some information about additional team support. The reading on Introduction to Artemis Mission is also linked on our main site, so you can read it from the webpage. Kim Weaver, who is here, was nice enough to actually put grade leveled versions of that reading. So if you're, for example, working with younger students in grades 3 through 5, and you're like, "Ooh, they're not going to read all this that's in the manual," there is a grade leveled reading that you can link to on the website. And also it's in the companion course, which is our next bit. So the companion course is really cool. We're going to talk about it throughout the day. But the links to all the lessons on the companion course are there on the website, as well as a intro page that has some additional information about the companion course. And at the bottom, there's some additional links that are useful if you're using the companion course. And then last thing is the schedule and team recognition. So this will help you understand what you need to do in terms of submitting results for your team in order to get your team recognized by NSBE and by NASA. All right, cruising along. The schedule. Okay, so we're cruising along on our schedule. We're on our first item here on our list. If you go down here, the main things that you should pay attention to are some of these submission dates. The initial submissions are optional, and I'm going to talk about that today, but it is a nice kudos to your team, and it also helps your team stay on track if you can submit to those initial submissions. And we know you guys are still actively doing the challenge. We can send you guys a little prize or give you a little recognition. So those dates are on the schedule there. A couple more support sessions. And then there's some weeks where we're going to have NASA expert talks. I have to be honest with you, I'm trying to find, like, nail down the time for the one that's happening in a couple of weeks. I'm going to hopefully do that by the end of the week, and that will be broadcasted out. But all of those talks will be recorded and posted on NSBE's YouTube page, so you can also watch them later if you're not able to watch them in real time. All right. Next little bit for the intro, supplies. So a lot of you guys should have already gotten your supplies. If you didn't, Deanna is our supply master, and she is here to answer all of your questions. She's got all the spreadsheets open. She's ready to see where you are on that spreadsheet. But these are the supplies that we sent out for the challenge. Okay, and we can talk and help and troubleshoot with some of these supplies with you today. The things that are highlighted in red, I wanted to point out, some of you guys already had supplies because you participated in previous challenges. Oh, Brandy, that's a good question. Yes, NASA Expert Talk is our way of saying SME. And SME, that's probably in the manual, which is left over. That's site. It's very NASA, one of NASA's acronyms. It stands for Science Matter Expert. But yeah, they're the same. So good question. We've had a couple of those questions. But yeah, so I wanted to point out the things that are highlighted in red. If you didn't ask for any supplies because the options that were on the registration form were the ones that are in black text, but you probably don't have regular simulant sitting at home in your classroom or in your house. If you want the red supplies, there is an additional request that you can send us, and we'll just send you those supplies to help you complete those mission objectives with your student. Okay, so that's just kind of intro to the Artemis roads before we dive in to some of the specific mission objectives. So I wanted to take a break here and see if there's any questions about this initial content. So where to find information, supplies, or if you would like to update your contact info, or if you have questions about how to do that. There's maybe that.
Here we go. Hi, I unmuted myself. I got it before anybody told me to. For those of you that are joining us, please check your emails the email address that you provided for us, and your voicemails. If I'm leaving messages for you, it's because I need to contact you. We are verifying addresses and letting people know an approximate time when they can expect to receive shipments that we've sent out, so that you guys have a real good idea of when you when you know things will be there. So please make sure you're checking your emails and checking voicemails and responding quickly to us. We appreciate it.
Yeah, that's a good point. Yeah, in some cases we've sent supplies to addresses that didn't work, or maybe people didn't know they needed to be there to sign for it. So we're just being extra careful. Okay, if no one has questions, then we'll keep, oh, we got one. Okay, so that's a good question, Stephanie. When we do find the time for that, we will put it, there's a couple of ways you can find out. We will update the events page on the NSBE webpage, and that's updated with all of the challenge events already, but not the specific time for the NASA expert talk. I'm also going to blast it out on social media. So if you guys aren't following us on social media, if you don't use social media, I understand. But if you do, if you follow NSBE, then that's a good way to stay updated. And we actually will also send you an email. Okay, so we're going to send just the mission advisors periodic emails, just reminding you guys about upcoming events. So we'll do that as well. And by the way, the NASA expert talks aren't just for people participating in the challenge. If you are a teacher and you have a classroom full of students that might be interested in watching the talk, or maybe a club or something like that, everybody is invited to watch and participate. Does that help answer your question, Stephanie? So we want you to be there, so we're going to tell you as many ways as we can think to do it. We won't, maybe Deanna will call you even, probably not though. Okay, so we'll move on. Again, what the challenge really is a set of mission objectives. So 9 mission objectives and then one fun one where you can describe something that went wrong. This particular session, we're going to focus in on the first 4 mission objectives. I'm frankly not going to spend a ton of time on the first 2 because those ones are fairly straightforward, and then we'll focus in more on the 3rd and 4th one. Okay, before I do that, we already introduced Kim at the beginning here, but I'm going to throw it back to her because she is the lead developer of the companion course, and it's really important that you guys understand this resource.
Okay, awesome. So on your screen, what you are seeing there is a diagram. The companion course is broken up into 5 units, and the units each have 2 or 3 lessons. And then most of the lessons are associated with a mission objective. So you can kind of see the lines there. Unit 1, lesson 2 is associated with mission objective 1. The reason that this is important to know, even if you're not going to be teaching this in a formal education setting, if you get confused about a mission objective, you can go to the companion course and get more information about one way that you could execute it with students. We have lessons written in the 5E format, if you're familiar with that. And they're also aligned to the next generation science standards. So if you are someone who's teaching in a formal education environment, and your administrator or someone is like, what are you doing in here? It looks like chaos. You can be like, well, yes, it is chaos, but it is chaos that is aligned with these NGSS standards. So that can be helpful for a lot of folks. And you do not have to do the lessons or the mission objectives in this particular order. So I know a lot of you said at the beginning that you had already started working on the mission patch. That's totally fine. But I would say that this companion course is super helpful if you get stuck. You can also reach out to us for help, but if you get stuck, consult the companion course. Just one other thing about the companion course that's new for this year, it is modified for upper elementary, so like grades 3 to 5, middle school, and high school. And so again, if you are teaching high school students, but the high school lesson is confusing, or perhaps your students have learning gaps from, I don't know, 2 years of a pandemic, you can always look at the middle school, or if you're in middle school, you can look at upper elementary to get ideas on how you want to handle this. And you are not required to do these lessons. They are there to support you only. And please check them out. And if you have any questions, reach out to info@NSBE, and they will get the message to me and I will help you. Anything else, Darcy, that I missed?
No, that's perfect. Yes, thank you, Kim. And yeah, these lessons are really great. So you'd really, even if you don't even think you want to look at it, take a look, because they're really well developed and they have a lot of good resources that your students can use to help get started on all the mission objectives.
And soon they will be available in Spanish. That was the
Oh,
one
yeah.
thing that I was going to add. Right now we have the English up there, but we do have a translator who's working on getting everything available in Spanish as well.
Yes, thank you for bringing that up. Okay, well, with that in mind, we're actually going to pull some of the things that are in the companion course to help you guys get motivated to learn about our mission objectives. So for the first one, again, this is helping you guys understand what's in the companion course, but also a trick that you can play on your students if you're trying to get them motivated. We'll do a little warm up. So we're going to talk about mission objective 1, which is the mission objective where the students develop their mission development log. But before we do that, I'm going to ask you guys to do the engage part of the lesson that Kim developed for this mission objective. And tell me what kinds of information is being recorded in the pictures that you see, and why do you think that information is being recorded? So you can unmute or you can put something in the chat. Oh. Yep. Nice. Thank you, Brandy. Yep. Thanks, Chris. That is a fact, Kim. If they're not like in my digital calendar, just count on me not showing up. Can't say it never happens. Okay, so that's some of the stuff that we're seeing. Yeah, why is it important to record that kind of information? What do you guys think? Goals, yeah, right? Why might we? Okay, yeah. Okay, maybe somebody wants to boldly unmute themselves and tell us all, why might some of this information be recorded? Why generally do you think this type of information is recorded?
Yeah, so this is Jesse Hayes. So the journal thing, right? I mean, it's good just to make observations of what's going on.
Mm-hmm.
Done. You've got a to-do list, right? So if you're, you've got some mission objectives that need to be done, and so it's good to have just a tracking of the things that need to be accomplished in order to be successful. Here on the bottom left, I'm looking at that more as a process flow or maybe a work in progress board, and you're just keeping track of who's doing what when, and everybody's role in it. That's very important. And then data collection is absolutely important in science and engineering. So you're collecting data and observing the data and pulling inferences and conclusions from it.
Yeah, thank you, Jesse. And if you guys don't know, Jesse Hayes, he's one of our partners with Red-Tailed Hawks, and he teaches young people how to fly airplanes, which is not for the faint of heart. So I don't know, Jesse, when you are flying airplanes, do you guys keep a record of things that happen during flight?
Interesting enough, not as much as we used to.
Yeah.
So much is recorded electronically these days, but we do track flying time. We have to track, how many hours are being put on an engine. The FAA has rules about inspections and overhauls and things that are required, whether they're needed or not, which is very expensive and frustrating. But but there are maintenance schedules that have to be followed in order for it to be considered airworthy. So yeah, all that's important.
Very cool. All right. So what we're trying to do now, get you guys thinking a little bit, but this is a good way. If you're a young person, if you're a 3rd grader or 5th grader, the idea of writing something down and keeping track of what's happening and why you might do that might be a little bit of a foreign concept. So it's a nice way to introduce a reason for actually creating what they need to create, really to do the challenge at all. This is not an optional mission objective, to create the mission development log. And this is a record of what the students are doing during the mission. This is what they submit to NESB for us to know what you guys participated in and what we can reward you for. And this one is pretty straightforward. I will give you guys an opportunity to ask questions, but there are some specific rules in terms of what we would like this mission development log to look like this year. 40 pages or less. That could be a Word document. It could be slides. It could be website pages, however you want to interpret that. I know that people have used a variety of modes to make their mission development log. But really, it's just a record of what the students are doing to complete each mission objective. But in particular, you want to make sure you address what's called the deliverables at the end of each mission objective for the grade level that your team is participating at. That just helps us make sure that you guys are kind of extracting what we'd like you to extract from the challenge, and we can kind of like see what the different teams are doing and compare it that way. When you guys share this back to us, it's just a little tidbit, like make sure that we can see it. Sometimes like we get shared, Google Documents get shared to us quite frequently that we actually don't have permission to open. So just do a double check. That way we can actually see what you guys submitted. So like I said, I probably already spent more time than I wanted to, but for each of these.
Can I ask a question about the
yeah.
format real quick?
Go ahead,
Because
Jesse. Yep.
I think that's the first time you've kind of dictated that it be a PDF. Last year we gave access to the Google Drive. And
Yeah.
it went well because all the pictures and all the data and everything right there to be observed.
Yeah, the issues with giving access to a Google Drive is it's sometimes not as organized to us as it might be to you. And, you know, file permissions can be a real problem. And so organizing it into a single Google document and then exporting that as a PDF, that doesn't work as well for videos. And video is also an option to be put in there, but you can put like links to YouTube videos or whatever.
Yeah.
Okay.
Is that okay? It does get to the point of like, you collect a lot of information on an activity like this, right? Like maybe you took 100 pictures, but what are the pictures that really are important and tell the story? So instead of teams submitting 100 pictures to us, like what are the 4 pictures that really represent what went on? That helps us because we actually don't have time to look at 100 pictures from every team, but also I think it helps you guys think about what's important to keep in that kind of record and helps the students as well. For each of these, again, I want to highlight what's available in the companion course, which is linked directly in the manual for each mission objective. So that engage thing that we just did is part of the companion course. So the companion course lesson will help students discover why record keeping is important. There's links to explore past mission development logs from past challenge teams and other science and engineering notebooks. Yeah, Brandy, website is fine. Just link it and try to make sure it's within 40 pages. There will be availability to send us a link. One of the activities in the unit is to have the students make a timeline for the challenge, which actually is super helpful for trying to figure out what mission objectives you can accomplish in the time that you have and to keep the team on track. Okay, so that's what's available there. Yeah, so feel free to ask any more questions on mission objective 1.
Hi guys, this is Deanna. I'd like to chime in real quick regarding the mission development log. We really would appreciate it if you put it in the PDF. Sometimes schools will not allow outside organizations the ability to view the website. You guys see it fine, but we can't get to it. So really, if you can bump it down to a PDF, you make our lives so much easier. We have a very short window to get everything evaluated and back to you all. And it's a very short window. And there's only a few of us, and there's almost 400 of you guys. So please, if you can put it in an MDL, in a PDF, we'd really appreciate it.
Okay.
Thank you.
Any more questions? All right, moving
Yeah,
along.
that's fine, but I think it's still gonna need to be shared by a Google Drive or something because a PDF that big is not gonna be emailable.
We can upload, you're going to upload a PDL to your MDL to us in a PDF format. It's uploadable.
Okay.
You'll
Okay.
upload it directly to the website. I think the limit is like 500 megabytes, which is pretty big. So,
Okay. All right. Cool.
okay. Yeah.
We'll
And
do
we
that.
can add, like, again, we can get down to the nitty gritty of that when we get closer to submissions. These early submissions are a good opportunity for us to, you know, test out the uploading process and make sure everything works. Great. Okay. So moving on to the next one. Okay. So mission objective 2. Again, I want to do a little warm up to get you guys just thinking about what we're hoping to get at for this particular mission objective. So if you guys can take a moment, I'm going to put a link in the chat. And I want you to open that link and just explore this 13 moon calendar. And just take a moment and take a look at it. And then I'll ask you guys some questions when you're done. So about a minute or so, just kind of click around. Let's see. Okay, I'll bring everybody back. Luckily it's a kind of a quick one to click through, but what you're looking at is a calendar of the First Nations people that live in the Pewichalwenaki, which is in Canada. It's a land in Canada. And they were kind enough to provide this resource on their website. And what I'm curious about from you guys is when you're clicking through there, what did you find interesting about this calendar? Is there anything in particular you found interesting or maybe that you wonder about?
I like the emphasis on the relationships to the elements, the food, as well as the plants, the animals, and all within the 13 moon cycle. It's great. I work and teach here within our Navajo Nation, and we have here at our school a lunar calendar that informs our interdisciplinary units of study, and this one here is inspirational. I have to share it with our Denali language and culture teachers.
Very cool. Thank you for sharing. Did anybody else find anything interesting, or is anything they wonder about? Yeah. Thanks, Chris.
Yeah. How do you use it?
How do you use it? Yeah, that's a good question. So there's things about this. There's numbers, right? So there's pictures and descriptions, but there's also 13 moons. And then if you look around the turtle's shell, how many numbers are there?
28, which looks like a moon cycle, I would imagine.
Okay. Yeah. So again, we're just trying to get you guys warmed up for thinking about this. But yeah, this is a lunar calendar. So it's a calendar that's really not so different than the kind of calendars that we have hanging on our wall where we keep track of time. It's a different way of thinking about it. So in many Native American cultures and other cultures, they have names, like not even just Native American cultures, right? Farmers have names for particular full moons. And we could think about why that's important to do that or why it's useful to do that. And that's what we want students to be thinking about for mission objective 2. So moving along here. Okay. Oh, my slide's not working. Come on. Hold on. Why is that not working? 1 second. There we go. It's just being slow. Okay. Go back one more. All right, guys. My slide transitions they were working. Okay. Might need to stop presenting and start again. Hold on. Let's see. No, that's not what I want. Okay. Sorry, guys. Let's see if I can get this working again.
Do you want me to see if I can share, Darcy?
No, I think just need to scooch this over. There we go. Okay. All right, so mission objective 2, it is an objective where we're hoping that students learn about the lunar cycle and lunar phases, but we also want students to think a little bit more broadly about that and make a connection with the moon and why the way that people made connections with the moon basically for thousands of years, using it as a calendar in the sky and connecting it to meaning in their community. So again, this mission objective, I don't think is too challenging in terms of how to go about it or understanding how to go about it. We're asking students to make at least 2 weeks of lunar observations. We prefer that they do that by eye, which means they go out and actually look at the moon with their eyes. But if they need to do that using virtual resources or supplement that using virtual resources, that's okay with us. But once they make these observations and actually observe the cycles of the moon, we would like them to design a lunar calendar, okay, that has a theme or story. So a month-long calendar that is based on a theme, similar to what you guys just looked at, how those full moons were aligned with a theme that was related to what those peoples were doing during that time of the year. And then at the end of the MO, we're asking the students to answer some additional questions about the surface of the moon and lunar phases, just to get them to think a little bit more deeply. Again, there is a lesson from the companion course that's aligned with this that actually will really go deeper into understanding lunar phases and hit some of the standards related to that. And this is just showing a screenshot from a simulator that we introduced in that lesson that students can play with in order to better understand what causes lunar phases. There's some tools in there to help students determine lunar phases on future dates, which is something we asked them to do in the mission objective. And there's also many more links to cultural resources, including books and websites, if you want to help make those connections. Okay. All right. Questions on this
I
one?
haven't really looked at this too hard, but
Yeah.
on the observation part, so when we had the periods of obscuration and non-visibility,
Yep.
is there an electronic tool that they
Yeah.
can go to would say when?
Yep. In the resources, we link to some electronic, like basically online tools where students can observe the current phase of the moon. Or if you really want to challenge your students to think, you can ask them to infer what the moon might look like before they look at those resources if they're just kind of missing a day or two in the middle of some eye observations. But yeah, we know it can be hard, especially, you got to be out there we're hoping that they make observations at the same time of the day, or at least when they can see the moon. So but yeah, we understand that it's not possible for everyone to observe it with their eyes. Does anyone have any other questions on this mission objective?
You have a question from Stephanie Hanover. She wants to know if they turn in their moon story or by team. So
we're hoping
turn in.
So we're hoping, Stephanie, this is a group project. So for a lot of these mission objectives, we're hoping that they do it as a team. So we're kind of hoping that the team comes together and makes one lunar calendar. So you guys can decide how best to do that with your team, but we're really only expecting one lunar calendar per team. Yeah. One thing I do want to emphasize here, some communities are not comfortable sharing their connections to the moon or their moon stories out into the public, or even maybe with other people that are in their classroom or their teachers. So if you're asking students to go ask their elders about lunar stories or moon stories, make it clear that they don't have to share it back. And if you need to put that in the material you submit to NSBE, that this is culturally sensitive information that is not appropriate for sharing, just let us know. We don't need you to share it back. Just let us know you did the activity. Okay, moving along. Warm up. So now we're getting into some of a little bit more challenging, I think, to do MOs. So this one, I'm going to do the warm up pretty quickly because we're getting behind. This is NASA's Viper mission. I want at least 2 comments in the chat about why you think it might be hard to drive on the moon. Regolith. Can you be more specific? What about regolith might be hard? Rocks. Gravity, okay. It's powdery, yeah, exactly. Yeah. Lack of traction. Yep. Traction. Yeah, big one. If you've tried to drive your car on the beach or a bicycle in the sand, yep, you've experienced that. Okay, dust. I'm not going to ask what that stands for. It sounds like a rock band name or something. Okay, you guys are on the right track. So for MO3, we're actually asking students to investigate the moon's surface in order to discover why it's hard to drive on the surface of the moon. This mission objective is connected to MO7, where they actually design their robot to address some of these challenges, and they test it in MO7. So the two kind of go together. It would be hard to do MO7 if you didn't do MO3. You could just do MO3 and not MO7, but most of you guys want to do the robotic or rover part of this challenge anyways, okay? There are 3 parts to this mission objective. The first one, students explore the surface of the moon using NASA TREX. Part B, they explore lunar simulant and find a similar material. So we actually sent you guys actual simulant that was made in a lab to be like lunar regolith. They should explore the properties of that in order to figure out another material that is similar to it. So a simulant for the simulant. And then part C, the students will be brainstorming about challenges of driving on the moon and develop and design a prototype wheel. And I'm going to skip this just because I think we're running a little bit short on time. But all of you guys, before you have the students do it, I encourage that you guys check out NASA Moon Trek first, because it can be a little bit challenging to navigate. And I want to point out that on NSBE's YouTube page, there is a somewhat long video, but you can watch it in double time. It's about 15 minutes. It's more targeted towards adults or mission advisors, where it will show you how to navigate through and put some important layers on NASA Moon Trek. You could also, if you have an older student, give them the link directly, but it would be a lot for a 3rd grader probably to follow. Okay.
And also the student handouts in this lesson plan have step-by-step instructions as well. So if you prefer written instructions, check out the student handouts for this lesson for middle school and high school.
Yeah, that's a good point. So that's part A. So really what they're looking for in part A is they're trying to discover, and I'll talk about the lesson as well at the end, the slopes on the moon. So Moon Trek is a good resources for understanding kind of the steepness of getting in and out of craters and up and down ridges on the moon. Part B, I already talked about this. So students are going to experience the regolith. So they'll touch it and feel it. They can use the microscope, like the Foldscopes we sent, to look at the grain size. How big are the grains? What are the shape? Why is the shape important? I don't know. Let's think about it. Okay. And does it react to different objects? How does it mix in water? Okay. So the way, again, we're having teams discover a material that's like the simulant, because eventually we're going to ask them to drive through something, and we're not going to send you guys enough lunar simulant for the robots to drive through. So they're going to have to drive through that other easy to acquire material. Okay. Part C, again, students need to design, aka draw, and describe a wheel for this MO. For this mission objective, they don't actually have to make the wheel. They just have to describe it. but they can go that next step and choose to modify or design a new wheel. They can use craft supplies to modify the wheel. Secret's out, I did it and it worked. I used like very common craft supplies and the Lego wheels to get it to work. But they can also, if you have this resource available, they can 3D print their own wheels. And there are designs online to start with. So if you Google like Lego wheel design, you can get 3D print files that they can modify or try. Okay, so like Kim brought up, there are a lot of useful resources. This is a harder mission objective, but there are a lot of useful resources in the companion course. One of the most useful, I think, again, is these handouts to help students use NASA Trek, but also to help them understand how to interpret data that they can derive from NASA Trek related to slopes. So this is, again, Kim Weaver developed these. This is a nice slide from the materials where students can compare the experience, right, of a rover driving up out of this crater along those 3 different paths. Okay, and of course, this is exactly how NASA has to think about it too. You guys can think about which path would I choose, you know. Okay, so again, if you're like, whoa, this one seems hard, you're just reading the manual, check out the companion course. There is a lot of resources there. All right.
There's a couple questions in the chat.
Well, I have question time here. Yeah. Okay, let's see. Can flour, Chris? Yes, that might work. Have the students check it out. So that was maybe flour mixed with various bead sizes. If you have questions while lesson planning, you can reach out to info@NESB, and we will send it on to Kim Weaver if we think that we need that firepower to answer the question, or we'll try to answer it if we don't, we need that firepower. Lego tank tracks are acceptable for sure. Yep. And will gravity augmentation? No. We will not consider the augmentation of gravity. That's too hard for us to reproduce here on Earth. You could have the students consider it for sure when they're designing it. But yeah, we're just thinking about really the challenges of slopes and the challenges of driving in the regolith. Any other questions on that? Okay, I am behind as always. So if you don't mind, stick around a little bit longer because I'm going to hand it off to Kim for perhaps the most interesting, but also maybe one of the more challenging mission objectives that we're talking about today. So go ahead, Kim. I'm going to hand it off to you.
All right, awesome. And if you can't stick around, this is being recorded and it will be shared out. So apologies for going over time. But this is definitely a question that we're going to get a lot about mission objective 4, which is about life in closed systems. So here you see 3 sealed containers. No matter can get into or out of the jars, but some kinds of energy like light and thermal energy can get in and out. So this is the warm up for this lesson plan in the companion course, just to start people thinking about, you know, how does it work when you enclose life into a closed system? And there's also a little brain teaser in there about why does NASA care about closed systems? Because they put human beings in closed systems and send them far away. So just looking for something in the chat about which jar is most likely to get really nasty the quickest? Which jar is most likely to get really nasty the quickest? If this is a sealed jar, no matter in or out. All right. I'm not going to ask you why you chose B, but I see a couple of choices for B. Oh, C might get really nasty. Interesting. We have a diversity of thinking. All right. We have a few people who said C and a few people who said B. If we were not horribly behind the time here, I would ask you to fight it out using not your fisticuffs, but rather your best scientific reasoning as to whether it was B or C. But thank you for sharing your ideas in the chat. Next slide.
Okay, let's see.
So after students engage in this idea, what we ask them to do is to design an experiment that is going to teach them something about a closed system. Closed systems, especially when it comes to NASA, are very, very complicated. And there are a lot of experiments that you could design. In your kit, for this, if you requested a carbon dioxide detector, you'll get one of those. They're very sciencey and very fancy and allow you to measure CO2. And then you'll also get a light if you requested a light. And so if all you had were these two pieces of equipment, you might be able to design a testable question saying something like, how does whether the light is on or off affect the carbon dioxide level of a closed system? Or you could get a thermometer and you could measure temperature. You could talk about air filtration or water filtration, like which material is best at filtering CO2 out of air, something like that. And there's a lot of guidance again on picking a testable question. If you are teaching small fry, it might be something simple like, how many days does it take for beans to sprout or something like that, because that could be something that NASA is interested in from plants. So this is a big lift for students who have never been asked to design an experiment before. We know that, and we've provided a lot of things that will allow you to scaffold for your students.
Okay.
Do you grow the plants in closed systems? You can, or not. I mean, it's really up to you, as long as you're designing an experiment where there are controlled variables, independent variable, dependent variable that you can observe or measure. It can. Oh, and I also want to take a field trip to Biosphere. It is a life bucket list thing for me, absolutely. And in our recommended book lists for this course, there is a great, I would say like a middle school level book about Biosphere 2. You should definitely check it out.
Yes. I want to emphasize here, when I talk to mission advisors about this one, there is a lot of questions about whether the question is a testable question. So this is like the essence of this. It's more important that the students know how to create a testable question than what they actually decide to test. With that in mind, sorry, I'll go to the next slide, Kim.
No, that's fine. That's fine. It's true. I mean, it's a big lift for teachers too, who are used to giving students a recipe for an experiment and asking them to follow the recipe. This is very, very different. And so we're asking you to take a leap of faith that is aligned with the next generation science standards, science and engineering practice that asks students to plan and carry out an investigation. And then the deliverable for this is a model of how closed systems work. And there are resources in the lesson that explain the difference between a drawing and a model. A drawing shows you how something looks, and a model helps you describe how something works. And so definitely this is a big aha moment for a lot of students and a lot of educators. A model just looks like the thing, and a drawing just looks like the thing. A model actually shows you how it works. And the Google slide presentation will probably be available, and this recording will also be available. And these slides, some of them that are student facing, are in the companion course as well. So we want them to be able to say something about how a closed system works. It could be something simple like humans excrete carbon dioxide, plants take up carbon dioxide. So if you put a human in a closed system with a plant, then nobody's dying from carbon dioxide overload. So even simple things like that they might be able to figure out from their experiments. And so this lesson is the most science heavy lesson. It is asking for a lot of big lifts from you and your students, but really hope that you will take it on board. And, you know, last year, if you did last year, this is similar to the yeast lesson that we did last year, which we got some great responses from teams on. So we're very excited to see what you do this year.
Excellent. Thank you. All right. Questions on life in a closed system? Or if you don't have questions, throw some ideas in the chat. Curious to see what people are thinking or what their students are thinking.
It makes me think about a greenhouse for the moon or Mars. That's
Mhm.
also the Biosphere 2. And when we have a greenhouse here on campus, and then some of my students here have greenhouses in their backyards, and so we make the far transfer between that and a closed system. They're not all that can
Right.
be comparable, but they are with the biosphere too. So it's exciting. Then the students also think about what are the implications for a biosphere 3 on an international space station going around another planet and all that kind of stuff. So it does lead to a lot of creative questions and inquiries. So I
For
appreciate
sure. And from a NASA's perspective, we like adding this because there are a lot of people that work for NASA that are not designing rockets or looking at stars, right? There are life scientists that work at NASA and think about these kinds of problems. And so if you have students that connect more to the life sciences, then this is a great mission objective for them to take a lead on.
Yeah, I also think that there's some overlap with astrobiology too, and so
Yep.
that leads to all kinds of questions and curiosities, and so
Yeah, if humans have to escape the Earth to live, for the next 1,000 years, like we have to, right, create our own closed system in space somewhere. Can we do it? Yeah, for sure. Okay. Again, questions, you can pop them in the chat. I do want to keep going just because, again, like all talks that I give, this one's gone a little over, which is fine, except for the seminar I gave last week, which was surprising. Okay. So I know a lot of you guys are curious about how your teams are going to submit results and achieve or reach our levels of achievement or basically get recognized. And this slide is a little bit busy, but I want us to focus in on right now the first one, which is the one that's due on February 15th. This one is called Launchpad Status. And I want you to notice that it is optional, which means if your teams don't submit anything for this, they are not kicked out of the challenge, okay? This is just an optional thing that you can kind of prod them to do in order to stay on track. If your teams make a submission, the submission page is already open online. We are going to, after February 15th, we'll recognize them on social media. So we'll put their mission patch up there. We'll give them a shout out. Okay, and so they'll be recognized. So for that one, you need to have the teams complete a mission patch, which I know is one of the later mission objectives, but we're putting that one earlier if you decide to do this. And then just one entry for some other mission objective, whichever one they decided to complete first in their MDL, okay? So I'm just going to stop there for a second. Does anyone have questions about that? Oh, okay. Email sent. All right, I will check that out, Brandon.
Yeah, actually, I do. I had a question about submission times. I develop a lot of times. I had like an early afternoon cutoff time. Do we get till midnight or?
You'll get till midnight. Yeah, we're not
Okay.
paying attention at that level. We're not sitting there. Yeah, we'll get till midnight. That's a good point, Brandy. To be honest, the manual thing we wrapped up quite a while ago, and we've been working with our hub coordinators, and things might have changed a little bit. So I'd have to take a second to actually, unless you could tell me what the exact difference is. What I will tell you is if you go online on the website right now to the submission page, it tells you what we're looking for and how you submit it. So, and it might not hurt to, even before you submit, just go kind of click through just to see what that submission looks like, so you know you're ready when it comes time. But yeah, I apologize for that. Okay, so if there's no questions about that, the next one again is an optional one, March 15th.
Hey, Darcy.
Yeah, go ahead.
Just really quick on the email that was sent out.
Yeah.
It said the only thing that we needed to have, that the team should submit a team name, the mission patch.
Yep.
And then it says the only main difference that I could find was that it says an MDL entry, which is MO1, which we understand, entry for at least one more mission objective. So we only have to have one entry for the MO2 to MO7 choice, or so just one entry, or do we need to try to complete it?
No, just one entry. So basically, because MO1 isn't really its own mission objective, it's kind of like start your MDL. So if you started your MDL and then made an entry for one more mission objective, so say you completed the
Like MO3.
Yeah, or Pack My Moon Kit is one the team could do in just a couple of days, probably, or an even.
Okay, so it doesn't. So the mission objective does not have to be completed. We just have to start it. Or am I reading that wrong?
That's if it's a longer one, you can just have started it. So say it's MO4, what we just talked about, and they're doing a long plant investigation. That's okay if they've just started it. Some teams might have picked one that they fully completed. We're going to be really flexible, and we're not trying to be like wishy-washy on that. We're just trying to get you guys to make sure that you're started and we recognize your team. So as long as, you've made reasonable amount of work towards one of them, that's fine too.
Yeah,
Okay.
I think the thinking behind it is some teams have gotten really excited about doing the tasks
Yeah.
and that they leave the documentation behind until the very end, and then they never get the documentation rolling. And so it was kind of written that way because we're looking for proof of life that you've started the mission development log. And that to me is, the main thing, the main reason why it was written that way.
Yeah.
Okay. And our mission development log, like what we start with now, it can also evolve and change to our final one that we submit, correct?
Yeah.
Okay.
Fine. Yeah. And this is, you did this last year, Brandy. This is basically like the checkpoints that we had. We just decided to uncouple them from specific mission objectives and kind of let teams choose which ones they wanted to do.
Okay. Thank you.
Okay. So with that in mind, the next one, low Earth orbit, is similar. It is another optional checkpoint, but we're just asking that the teams basically commit or complete one more mission objective. Again, their choice. And then this is more important. So if your team wants to go to one of our final events, which are going to be in person this year, they do have to complete an additional 2 MOs. So that means they have to complete, and I'll put it in the chat so it's clear, because actually it's not that clear on this slide. 4 MOs between, my computer just went to sleep. 4 MOs between MO2 and MO7. So let me get back to here. Okay, so 4 MOs between MO2 and MO7, which isn't too bad, okay? So if your teams do complete that number, then we will invite them to a hub event, and they'll also be invited to a virtual meetup with an astronaut, okay? If your teams complete all of the mission objectives that are part of the Artemis Challenge, they will also be invited to the hub event and the virtual meeting with the astronauts. But then they'll also become eligible to win a trip to Kennedy Space Center. So that's an extra incentive to complete the whole challenge. Okay. Yeah. Bye, Kim. Thank you so much. I appreciate it. Okay. So a lot of you guys might be curious. I'll give you guys a chance to ask questions on that again about hub and team locations. So this is an up-to-date map. I just updated it today. Okay. There are about 300 teams that are registered for the challenge, and you can see all the yellow dots. That's where the teams are. The red locations, those are confirmed locations for hub events. Okay, so there might be one near you. Hopefully there's one near most of the folks here. I know there's not one in California, but I do want to make it clear that if you are not near a hub event and you can't make it to a hub event for whatever reason, virtual submissions will also be possible. So there will also be like a virtual hub where teams can submit their results virtually, and we will treat them just like any other team. What you're seeing on the table is the actual specific locations and dates for the events, except for the one in North Carolina, which we don't have a specific date for yet. And this will be updated again and shared as we go along. Okay. But as now that the challenge registration is closed, I would expect you guys are going to get contacted by, if you're near a hub, you'll get contacted by your specific hub coordinator with some of this information. Okay, so a lot of this we'll talk more about in future mission advisor support sessions. We'll have more time actually to talk about the end of the challenge rather than the beginning. But I did want to share this with you. The last thing I kind of promised is a little preview of the final challenge course, which again, we're going to send out more details soon. Oh yeah, Boise, they don't. That's a good question, Brandy. So the final challenge map actually will be 3-dimensional. Students will need to drive into it along a ramp. Okay, so they'll be driving into the map along a ramp. This is the area where there'll be samples and obstacles for the teams to navigate around. And then at the end, Teams are going to exit up along a ramp. Well, they'll get to choose the angle of their ramp. Steeper, the better. Okay. So that's a little preview. This is why we're having students think not just about programming their robot and moving around in space, but programming it to move up and down steep ramps. And you can see some of the sizes of these. And we will be providing details of the 4x4 square here so that you guys can build a practice course at your location and your students can figure out how to program the robot before the final challenge of it. Okay, cool. All right. So a lot of information there at the end. I want to give you guys an opportunity to ask questions about team recognition. If you have initial questions about the hub events, or if you want, you can ask me a question about that final challenge map.
I have a quick question.
Go ahead.
So before we did this, which this works perfectly and it aligns perfectly with what we already do in my 6th grade classes, because we spend the entire spring semester doing space.
Mhm.
But my question is, so I already have some lessons that I do, some I'm integrating these. We're still doing the companion courses, maybe not to the T on every single one of them,
Mhm.
but we're trying to get through all of them. And then also do the things that we already had planned.
Yep.
My question is this, is like when they go to try to do their MDL and explain what they learned, is it okay if they have a little bit of overlap stuff from other activities that they did so that their MDL kind of makes more sense than if it's just pulled from only the things that they did here and it doesn't seem as complete? Is that okay if they have a little bit of extra information?
Yeah, that's okay. I would say that like if it's going to be a lot, because we do have that page limit, like for example, if you're having your students keep an MDL of like everything they did that whole quarter, maybe you could kind of use the table of contents. And if there's like a totally unrelated activity, you could just not submit that. But like
Right.
you can
We
see
would
the
just
whole
keep
table
those
of
out.
contents is still one document, but maybe they just delete those pages of the PDF. But yeah, that's fine. We can work around that for sure.
Okay, I just want to make sure that if they have something extra in there that seems weird, it's
Okay.
not, it's okay
Like,
if
man,
it came
this
from another source.
No, it's totally fine. A lot of cases, we do have some teams that will go, like if you're like a team that's like done robotics forever, sometimes they go above and beyond and actually challenge themselves a little bit more than what we have in the mission objective. So that's totally fine.
Okay, thank you so much.
Let's see, Brandy, I was recommended to have teams of 3 to 6, 7 or 8 members. Yeah, Brandy, do you want to go ahead and, oh, okay, Deanna will talk offline. Okay. That's fine. Yeah, Brandy, we are trying to keep that one a little bit stricter this year. Anybody else have questions on that stuff? Again, we're going to go over a lot of this end bits, the hub stuff and the final challenge map in future sessions. You'll get more information also sent to you. All right. If there's no more questions, I'll keep going. I know I'm keeping everybody late. I do want to remind everybody of the NASA expert talks. We already had one. It is recorded and you can watch it on YouTube. It was really cool. Patricia Moore talked about Artemis 1 and what it was like to watch the launch. Make sure that your students are participating in this. Like once the students start asking questions, they really gets interesting because you can see they're nervous to ask one, but then they have like 20, which is really fun. So we will make sure you guys know when those events are. And I know it's really hard to schedule. Sometimes it's hard for us to find a time that's good for everyone. So everything will be recorded and posted online. And we will give you an opportunity to submit questions early so that we can ask some questions for folks that can't be there as well. Additional support. So there's 2 more mission advisor support sessions that will go over some of the later MDLs and the final challenge details. We are offering bi-weekly office hours. So those times are all posted on our website. If you look on the events and announcements page, super casual, just drop in, ask us questions, and we'll help you out, whether it's robotics or the CO2 detector, or whether you think you're going the right way on a mission objective. You can always email us. There are some tutorial videos on the website, particularly related to the robots. There's a few that might be useful to you or your students, and you can call us, okay? So again, all right. Oh, that's an extra slide. That's my last slide. So if you guys have any more questions, feel free to stick around. We're up for sticking around however long. If you need to leave, we totally understand. We thank you guys for spending your time with us this afternoon.
If anybody has any shipping